Lesson 4.4, Parallel and Perpendicular Lines. Our essential question today is, how does the slope help you determine whether lines are parallel, perpendicular, or neither? So we're focusing on the slope in our equations, and that one piece of information can help us figure out parallel, perpendicular, or neither. What it means by neither is that the lines, they're not parallel, so that means parallel lines never cross, never intersect. They're not perpendicular. Perpendicular means they intersect at a 90-degree angle, so they're anything else. So those would be intersecting lines. They're not parallel, so they do cross. It's just that they don't cross at a 90-degree angle. So our first vocab word says parallel lines, and then it says parallel slopes stay the same. Parallel slopes stay the same. Okay, so parallel lines look like this. Two lines that never cross. So parallel lines have the same slope. Same slope. So they're slanted the exact same amount. They have the same steepness. They are parallel, they never cross. Perpendicular slopes, they flip and change. They flip and change so that they cross at a 90-degree angle. So here's one line. This would be my other one. They cross at a 90-degree angle. Okay. Then I'm going to add neither over here, just because I want to make sure that you understand what neither means. So neither means that they cross at an angle other than 90 degrees. Okay. Okay, so parallel lines never cross, perpendicular lines cross at a 90-degree angle, and neither means that your lines cross at an angle that is not 90 degrees. With the slopes, parallel slopes stay the same, perpendicular slopes flip and change, so that might need a little bit of explaining here. So if one of my slopes is 3/4, the perpendicular slope is going to be -4/3. So flip means that the fraction flips. It's a reciprocal. It's a reciprocal. And change means the opposite sign. So flip means reciprocal. And change means opposite sign. So two things are happening. Two things are happening with these perpendicular slopes. So the fraction flips and the sign changes if your lines are perpendicular. So anything else. So parallel slopes are the same. So it'll be like 1/2 and 1/2. The slopes are exactly the same. Perpendicular flips and changes. Anything else when you're comparing your slopes is going to mean that it's neither, that they're just intersecting lines. So parallel slopes stay the same, perpendicular flip and change, anything else neither. So this next slide, we're just looking at some lines, and we're just going to figure out what the slope of a line parallel to that would be, and a slope of a line perpendicular. So if you look at the original line, you should pick out the slope. So if it's written in slope-intercept form, that's going to be pretty easy to do. Parallel slopes stay the same, so keep it -3. Perpendicular, you have to flip and change it. So in order to do that, I'm putting a 1 under my -3, then I flip it over, and change the sign to a positive. So -3 is -3 over 1. I flip it and change the sign. Next one, my slope is 1/2. Keep it the same. Flip it and change the sign. So -2 over 1, which is just -2. Next slope, -2/3. Keep it the same. -2/3. Flip it over and change the sign. So it's +3 over 2. The next one, I'm going to put the 1 in front because the slope is actually 1 on this one. 1 is the same as 1 over 1. Flip it and change the sign, and it's -1 over 1 or -1. The last two require a little bit of work. This first one, I'm going to have to divide everything by 2 to get the y by itself. So y equals -3x plus 5. So my parallel slope is -3, perpendicular, flip and change, and it's +1/3. The last one requires 2 steps to get the y by itself. Add 2x to both sides. So 3y equals 2x plus 6, and then divide by 3, divide by 3. So y equals 2/3 x plus 2. So the slope is 2/3. Flip and change it, and you get -3/2, just like that. So if you can find the slope of the line, you should be able to figure out a parallel slope and a perpendicular slope. Find the slope of your original line. Now we're going to switch a little bit, and we're going to compare a couple of lines, and we're going to figure out if they're parallel, perpendicular, or neither. Parallel, perpendicular, or neither. So my first line, move this up, my first line, I'll graph in red, starts at 1, the y-intercept, and then my slope is down 3 over 1, so I'm going to move down 3 over 1 to the right, down 3 over 1 to the right, draw my line. Okay, my second one starts at the y-intercept -2, and the slope on this one is 1/3, so I'm going to rise 1, run 3, rise 1, run 3, draw my line. Okay, so it looks to me like these are perpendicular. If I compare my slopes, -3 over 1, +1 over 3, it did flip and change. So they are perpendicular. So this graph shows you what I just told you on the last slide, that if the slope flips and changes, the lines are perpendicular. You don't have to measure it on the graph because you can tell the relationship with the slopes. Okay, this next one. I'm going to graph the first I'm going to graph the one that's in slope-intercept form. So I can start at -1 and then go up 2 over 1 and draw my line. So this first line I'm making red. Now the second one, I'm going to need to solve first to get the y by itself. So I need to subtract the 3x to move it over to the other side. So that would be -3x plus 12, because you always want your equation in slope-intercept form. Then I divide everything by 4. So y equals -3/4 x plus 3. So start at 3 on the y-axis, go down 3 over 4, down 3 over 4, and then I can draw my line. Now these look like they are perpendicular, they intersect, they look perpendicular, so I'm going to compare these slopes. They did not flip and change. They did not flip and change. If they did flip and change, this one would have to be a positive 4/3. So positive 4/3 is not the same as 2/1. So these are neither. They're neither. The slope did not flip and change. Did not flip and change. So I'm just going to say neither. Looks close to perpendicular, but obviously it's not, because the slopes would have to be related in that way for it to be perpendicular. So it might be close to 90 degrees for that angle, but it's not 90 degrees. All right, next one. I'm going to start over here on the right because this one's easier. I just need to divide everything by 3 to get the y by itself. So negative 2/3 x plus 2. Start at 2, down 2/3, down 2/3. Draw my line. The other one requires a little more work. Subtract that 4x, it's on the wrong side. So 6y equals negative 4x plus 18. Keep it in slope-intercept order. And the negative is on the 4x, not on the 18. They've got their own signs. Divide everything by 6, and y equals negative 4/6 reduces to negative 2/3 x plus 18 divided by 6 is 3. So this one starts at 3 and goes down 2/3, down 2/3. So these are parallel lines. These are parallel lines. If I compare my slopes, negative 2/3 compared to negative 2/3, they are the same. If the slope stays exactly the same, the lines are parallel. This is a click and drag with some systems of equations. I'm going to look for parallel first. These slopes stay the same, so it's parallel. And these slopes stay the same, so it's parallel. Next, I'm going to look for perpendicular, so it has to flip and change. Flip and change. This is the only one with slopes that flip and change signs. These other two, negative 2/1 compared to positive 2/1, it didn't flip. It didn't flip, so it's neither. And then this last one, it didn't change signs. It didn't change signs. It was 1/5, positive 1/5, and then positive 5/1. So this one would need a negative. To be perpendicular. This one needs to flip to be perpendicular. So be careful, because each of those only had one thing that changed that was required for it to be perpendicular, and you've got to have two things. Both of them have to happen. Okay, you can write your summary now. Make sure it's complete sentences answering the essential question.